the positional relationship between a straight line and a parabola. In the Cartesian plane, we have two graphs related to a straight line and parabola. For example, first we give the parabola like this. For the straight line, its relationship with the parabola, we can categorize the positional relationship into three situations. First, we have the straight line here. It is obvious you can find out forever this straight line cannot cross this parabola. That is to say, they have no POI representing point of intersection. The second situation, this is the second situation, we assume the straight line just has only one POI with the parabola. So in this situation, we say the straight line is tangent to the parabola. Just one POI. The third situation, the straight line crosses the parabola at 2 points, here and here. That is to say, 2 POIs. We say the straight line is the second line of this parabola. This is the interpretation or demonstration of the positional relationship between a straight line and a parabola. From the algebra, we can analyze the positional relationship between a straight line and parabola. ax squared plus bx plus c. This is the quadratic function represented by this parabola. For the straight line, we can use y equals kx plus b. Of course, in order that we cannot mix with this b, we use x plus n to represent the straight line. So, if we want to figure out the positional relationship between the straight line and the parabola, we can construct the system of equations. That is to say, this expression represents the parabola, this expression represents the straight line. So, from the graph, we can figure out if these two equations have solutions, or we can say roots. That is to say, this parabola and this straight line, they have common point, but the common point, perhaps only one common point or POI, or two common points, two POIs. If the straight line is here, the parabola is here, from the graph we can judge there is no POI between this parabola and the straight line. So this system of equations has no roots. Okay, so we can make use of this this expression to replace this one. So we can figure out ax squared plus bx plus c equals mx plus n. Ax squared plus b minus mx plus c minus n equals 0. So the question is transformed to how to solve this equation. You can figure out here it is the x squared. A is the coefficient of this term. X its coefficient is b minus m. C is constant. N is also constant. So this is also a constant. That is to say, if we want to figure out the roots for this equation, we just need to use the discriminant. Discriminant equals this one squared minus 4 times a times this part, c minus n. This is so-called delta. It's discriminant for the quadratic equation. This is the discriminant if this value, if the result of this expression greater than 0, from the knowledge we have studied from the quadratic equation, we can figure out this equation should have two different roots. If this discriminant equals 0, we can figure out this equation should have only one root. If this discriminant less than 0, we can figure out this equation should have 0 roots. Okay, so this is the demonstration from the graph and from the algebraic perspective.